Okay, students, this lesson is going to be a form of a reteaching lesson using actual examples from DeltaMath to help you harness a bit more the content that I'm expecting you to be able to demonstrate on a future quiz when it comes to special right triangles. So I'm going to go over on how to approach these type of problems and take it slowly step by step. So if we look right now at this particular problem, a right triangle is given, the first thing that you are going to do is identify whether or not it's a 30, 60, 90 degree triangle or a 45, 45, 90 degree triangle. So as you can see, it's easily identified as a 30, 60, 90. So the first thing I'd want you to do is kind of space out on this first row the identifying degrees that your triangle has. Next, you will write down underneath it the ratios of the respective sides. So for 30, we're going to use m. For 60, m times square root of 3. And for 90, 2 times m. Okay? Now we're going to focus on what has been given to us and what we are looking for. So we are noticing that we were given a 2. I guess I should just circle it so that it doesn't cover it. We've been given a 2, and we're looking for x. Now, one thing I need you to identify is that these sides, the length of these sides are across from a respective angle. So for instance, the 2 is sitting directly across the 60, and the x that we are looking to find the length of is directly across from the 90 degree angle. So you are going to use that type of approach to put it underneath the correct angle. So the 2 we said was across from 60, so I'm going to put the 2 in the 60 column, and the x's is going to be in the 90 column. Once you have established that, what you are going to set up are 2 equations, and your equations are going to be the 2 given and find values that you have right there, okay? So what do I mean by that? So let's see where I'm going to do that. I'm going to come over here to the left, and I'm going to write down 2 equations. I have m square root of 3 equals 2. Okay, that's one equation. And let me make that 3 look more like, great. Let me write that again. M times square root of 3 equals to 2. And down here below, I'm going to write the other equation, 2m equals x. So what I want you guys to do is every single time, write the 2 equations, okay? Now, between these 2 equations, you have to decide which one you are going to solve for first. Obviously, I'm going to solve for the one that only has the m, because if I have 2 unknowns in an equation, it's impossible to solve for. Well, I mean, you can solve for it, a variable, but it's not going to help. So I'm going to solve the upstairs one by isolating my m. So I'm going to divide both sides by square root of 3. Divide this side by square root of 3. And in so doing, I got m to be all alone. And now I have 2 divided by square root of 3. Now, 2 cannot be divided by square root of 3, so I need to multiply the denominator and the numerator by square root of 3 in order to rationalize, okay? So I'm going to rationalize it, and 2 times square root of 3 ends up being 2 square root of 3, and square root of 3 times square root of 3 is square root of 9, but we know that 2 square root of 3 over the square root of 9 is just a 3. Okay, so our m is 2 square root of 3. So next, what are we going to do? Well, the answer that we got upstairs right here so happens to be our m value. So I'm going to come over here and I'm going to substitute that m right there. So I rewrite now the other equation. 2 times 2 square root of 3 over 3 equals to x. Now, 2 times 2 is just 4 square root of 3 over 3 equals x. Now, I want to make sure something. You see this 2 right here that I have right here? Too many times students multiply it by this number and by this number. You cannot do that. You can only multiply that 2 on the outside by the 2 inside. Remember, the first 2 here that you have that is black, that 2 right there, it actually has a invisible 1 underneath it. 2 over 1 is just 2. So that 2 multiplies with that 2 to get a 4, and 1 times 3 is a 3. So don't take that 2 and multiply it by that 3. You can't do that, okay? All right, so there's your answer, and that's what you would have typed in DeltaMath, okay? Let's try another one. So again, let us identify what our angles are going to be. Well, since this here is a square, we know that it's going to be a 45, 45, 90 degree triangle, okay? So let me see here. I wonder if I can move this up a little bit. Hold on a second. I'm going to move this up a little higher. There we go. Okay, so let us write out our ratios. So we just said it's a 45, 45, 90. So let's do that. So 45, 45, and 90. And with that, we have m square root of 2. Now, here we go. Our x and our square root of 8 are across from what? Well, our x is across from this angle, and our square root of 8 is across from this angle. Well, we know that squares all have 90-degree triangles. Oh my gosh, 90-degree angles. So let's say my x is across from a 90-degree angle, that's for sure. So I'm going to put an x right here across from the 90. And the square root of 8 is across from a 45-degree angle because this angle right here got chopped in half. So I'm going to put square root of 8 right here. It doesn't matter where you put the square root of 8 since we have 2 of them. So there's my square root of 8. So I have 2 equations I need to see about, okay? You write down the 2 equations. My first equation is m equals square root of 8. Just write them equal to each other. You see these 2? All I did was put an equal sign in between them. And then the other one, I'm going to put a line here to prove a point. The other one is going to be this equation. Write it down. M square root of 2 equals to x. So which one am I going to solve for first? I'm going to solve for this one first because there's no x. But there isn't anything to do. All right, m is already all isolated. I mean, look at it. It's all by itself on one side of the equal sign, so we don't have anything to do. So since m is already isolated, I'm just going to take my m value and go substitute. So that means the m downstairs has to disappear. When I have a substitute, I disappear and the sub comes in my spot. So m is now square root of 8 because we found that out. Here we have square root of 2 just comes down equals x. Now, since square root of 8 and square root of 2 both have a radical about them, I can multiply those 2, but I still need to remember that the radical needs to go over them because they both have radicals, so their answer has to have a radical. But the good news is that square root of 16 actually can be simplified because, whoops, the square root of 16 is just a 4. So my final answer I would type out is x equals 4. The length of this side here is actually a 4. All right, let's try it again. Here's another one. Oh, we got another 45, 45, 90. So 45, 45, 90, m square root of 2. Okay, so we need to find what is being given, and what is it that we need to look for? Well, draw your arrows or your lines to kind of give you a visual of what's going on. Well, I noticed that my x is across from 45, so I'm going to put it over here this time. And I noticed that my square root of 3 is across from 90, so I'm going to put it over here. And then I'm going to remind myself that this right here, that this right here, how do I do this? I'm going to do, there you go. This right here is an equation. And I'm going to remember that this right here is also an equation. And I'm going to write them separately, okay? I'm going to write them separately. So my first equation is m equals to x. I'm going to draw a line here so that you guys understand that I'm writing two separate equations. And the other one is m square root of 2 equals to square root of 3. Okay? So, which one am I going to solve for? I'm going to solve for the bottom one. Okay? So, I need to solve for m, so I need to divide both sides by square root of 2. Those disappear. Now I have m equals the square root of 3 over the square root of 2. Now, what am I going to have to do here? Now, here's one thing I want you to realize. If you had ended up with something like square root, making this up, square root of 10 over the square root of 5, you actually can divide those because they both have radicals and say 2. And then since they both have radicals, you'd say square root of 2. Okay? Square root of 10 over square root of 5 is square root of 2. You can simplify that way, okay? Now, why do I tell you that? Well, in this one, they both have radicals, but notice that 3 is not divisible by 2. So when that happens, you have to rationalize. So I'm going to rationalize by multiplying top and bottom by square root of 2. And then I just multiply horizontally, okay? 3 times square root of 2 is going to be square root of 6, because both of them have a radical. Okay, 3 times 2 is 6, square root of 6. By the way, if it was something like this, 3 times square root of 2, you would write it as this, 3 square root of 2. You have to keep them separate because this is a whole number, this is a radical answer. Okay, but if they're both radicals, combine them through multiplication. So square root of 6 over, whoops, I accidentally erased. I didn't realize I had the eraser on still. So square root of 6 over square root of 2 times square root of 2 is square root of 4. But we all know 4 is a perfect square, so square root of 4 is a 2. So that's our m, okay? I found my m. And when you find your m, you go to the other equation and you substitute. And when I substitute square root of 6 into the m and bring down my equals my x, I notice that actually I'm already done with this problem because our problem is looking for x. Okay, our x is right here. So that's what we're looking for, and we found it. All right, next problem. Find the length of side x. Oh, the side x in simplest radical form. Okay, so the x is the bottom one down here. Let me shift this up a little bit and see if this will help because it's kind of hidden. There you go. Now, another 45, 45, 90. So let's do it on this side. So 45, 45, 90, m square root of 2. Okay, so we've been given a 12, and we're looking for our x. Our 12 is across from 90. Our x is across from, and this is not wanting to work with me. See if I can do this better. There we go. And our x is across from the 45. So let us go ahead and do that. So x is across from 45. And 12 is across from the 90. So we are going to set these equal to each other and decide what we're going to solve for. So m equals x, and m square root of 12 square root of 12. Square root of 2 equals to 12. All right, so we're definitely not solving the one on top. We're solving for the one on the bottom. So I'm going to divide by square root of 2 on both of these, because my goal is to get m to be all alone. So m equals, so 12 divided by square root of 2. Those are not like terms. One's a whole number, one's a radical number. You can't divide them out. So I am going to rationalize. So I'm going to multiply top and bottom by square root of 2. So 12 times square root of 2 is merely going to be 12 square root of 2. Put them side by side. They are not like terms. Square root of 2 times square root of 2 are like terms. They are 4. So square root of 4. But we continue to simplify because we know that the square root of 4 is a 2. And as we write that fraction, what you're supposed to realize and catch is that this number 12 is divisible by the number 2. So we actually can rewrite it as 6 square root of 2. Notice that you do not divide the 2 into square root of 2. Those are not like terms. So 6 square root of 2 is my m. I'm done. I walk over to the other equation and I substitute the m with the answer I got in the other equation. And now voila, I found what x is. All right, my folks, we're down to the last one. Here goes this last practice problem. You have been given an equilateral. An equilateral entails that has properties that has all sides are equal. Okay, all the sides are equal in length. And because all sides are equal in length, that means all angles have to be equal. Now we know a triangle has 180 degrees sum of all angles. So if all angles are supposed to be equal to one another in measurement, 180 divided by 3 gives me 60. But I do want you to notice that this angle on the far right, the 60 degree, has been split by a bisector. So let us not write 60 on this one, but instead 30 and 30. Okay? So focusing on this part of the triangle, let's see if I can bring attention to it here. I want you to focus on this. I'm going to draw the orange here. So focusing your eyes on this one, we don't have to focus on the whole thing. We're just looking at this piece right here. All right. So notice that our x is now across from the 30 and that the 3 is across from the 60. So we're going to go set that up. Let's do it over here. 30, 60, 90. M square root of 3, and 2m. And then I'm going to put the lengths that we have found here. So the x goes across the 30, and the 3 goes across the 60. So here are my two equations. So let's start. The first equation is m equals to x. I'm going to leave a little space. And the other equation is m square root of 3 equals to 3. I will solve the bottom equation, the one with only m's in it. So I have to divide both sides by square root of 3. And I end up with m equals to 3 divided by square root of 3. Now notice that we cannot really divide those two numbers because they are not like terms. So I must multiply to rationalize that denominator, okay? I do not want radical denominators. I want rational denominators. So I need to get rid of that square root of 3. So I multiply 3 times square root of 3, and I end up with 3 square root of 3. And then square root of 3 times square root of 3 would just be a plain 3. And those two are going to cancel because 3 divided by 3 is 1. And now I have m equals to square root of 3. I am going to take my m and go put it in here. And when I replace it, I'm going to get my x. And I'm done. That's my answer. Now, every single one of those, I'm noticing we had m equals x, and I don't think I had m equals x, m equals x, m equals 8. Every single one of them, my goodness. I need to find one that looked more like this first one. Let me see if I can find one. Let's go back to problem number 5. Let me see if I can find one. Okay, so I found one here to help us. So 30, 60, 90. So let me write this down. 30, 60, 90. So this should be the last one. m square root of 3 and 2 times m. So what has been given to us? So we have been given an x and a 10. Well, an x is what we're looking for, right? The x is across from the 30. The 10 is what we've been given. So that's across from 90. So let's go type that in. So the 10 is across from 90. And the x is across the... Oh, no. This is also one of those... Oh, my gosh. This is so frustrating. You know what? I'm making this up. Let's erase this. I want you to pretend that the x is right here, okay? We're making up our own problem. I picked the wrong one again. So we are pretending that, where's my eraser? I am going to ignore this. This hasn't happened. And I'm going to wipe this out. So this is our new problem. That x is not there. Our x is right here. Okay, so x is across from 60. So yeah, there you go. So that's what our table is. X is across from 60. The 10 is across from 90. What are our two equations? Okay, so our two equations are going to be this one here and this one right here. So we write the first one, m square root of 3 equals to x. I'm going to write them side by side this time. And the other one's going to be 2m equals to 10. So which one am I going to solve for? Well, I'm going to solve for the one on the right, the one without the x. So I'm going to divide both sides by 2 to isolate my m, and I'm going to get m equals 5. Once you have found m, you travel all the way to the other side and dump it into the other m on the other equation. Substitute. So the m disappears and becomes a 5. Square root of 3 equals to x. I cannot multiply 5 times square root of 3. They are not like terms. And I stop, and that's my final answer. So I hope this helps, my dears. As usual, just reach out if you have any questions. Do not hesitate. Thanks for watching.